Myself, A. Divya, Assistant Professor, Department of Computer Science, Self, V.V. Vaniyapperumal College for Women, Virudhunagar. In this video, we are going to see about multi-stage graph problem using forward approach. So first we see what is multi-stage graph. So multi-stage graph is a directed and weighted graph in which all the vertices are divided into stages. All the stages are only directed from the vertex of the current stage to the vertex of the next stage. Both the first and the last stage contains only one vertex called the source and the destination. So next we see multi-stage graph problem. The multi-stage graph problem is to find the minimum cost path from the source to the destination, that is S to T. There are two methods to solve this problem. One approach is forward approach and the another one is the backward approach. First we see forward approach. In the forward approach, first we have to initialize the cost of k comma j which is equal to 0. Next we have to find the cost of k minus 1 comma j, that is cost of all the nodes j in the stage k minus 1. Next we have to find cost of k minus 2 comma j. Repeat this until we have to find the cost of 1 comma 1. This is the formula for finding the cost. So cost of I comma j equal to minimum of C of j comma L plus cost of I plus 1 comma L, where L belongs to the vertex in the next stage, that is I plus 1, where C of j comma L is the weight of the edge from the node j to L. Next we have to find the d of I comma j, that is the value of L that minimizes the cost. This is an example for multi-stage graph problem. In this, vertex 1 is the source and the vertex 9 is the destination. There are 5 stages in this graph. So first we have to initialize the cost of 5 comma 9 equal to 0. In the next step, we have to find the cost of k minus 1 comma j. In this, there are 2 nodes, 7 and 8. That is, in the fourth stage, we have 2 nodes, 7 and 8. So find cost of 4 comma 7 and cost of 4 comma 8. That is, 4 comma 7 equal to minimum of C of 7 comma 9 plus cost of 5 comma 9. We already know initialize the cost of 5 comma 9 as 0. So we get the minimum cost as 7. Next, similarly we have to find the cost of 4 comma 8. So minimum of C of 8 comma 9 plus cost of 5 comma 9. So we get the minimum value as 3. So for these 2 nodes, the node 9 gives the minimum cost. So for the cost 4 comma 7 and the cost 4 comma 8, node 9 gives the minimum cost. Next we have to find the cost of k minus 2 comma j, that is in the third stage. So we have to find the cost of 4, 5 and 6th nodes. So cost of 3 comma 4 equal to minimum of C of 4 comma 7 plus cost of 4 comma 7 and another one C of 4 comma 8 plus cost of 4 comma 8. So finally we get minimum of 8 comma 7. So the minimum value is 7. So for the cost of 3, 4, the node 8 gives the minimum cost. Similarly, find the cost of 3, 5. So, cost of 3, 5 equal to minimum of C of 5, 7 plus cost of 4, 7 and another one is C of 5, 8 plus cost of 4, 8. So, minimum of these two 13, 5 is 5. So, for the cost 3, 5, node 8 gives minimum cost. Next, find cost of 3, 6. So, minimum of C of 6, 7 plus cost of 4, 7, C of 6, 8 plus cost of 4, 8. So, we get min of 13, 5. So, minimum of these two values is 5. For the cost 3, 6, node 8 gives the minimum cost. Next step, we have to find cost of k minus 3, j. That is in the second stage. So, in this stage, we have to find the cost of the nodes 2 and 3. So, cost of 2, 2 equal to min of C of 2, 4 plus cost of 3, 4, C of 2, 6 plus cost of 3, 6. We already calculated these values. So, substituted these values, we get the minimum value as 8. For the cost of 2, 2, node 6 gives the minimum cost. Next, find the cost of 2, 3. So, minimum of 3, 4 plus cost of 3, 4, C of 3, 5 plus cost of 3, 5, C of 3, 6 plus cost of 3, 6. Substituting all the values, we get the minimum value as 10. So, for the cost 2, 3, node 5 gives the minimum cost value. Finally, we find the cost of 1, 1. So, cost of 1, 1 equal to min of C of 1, 2 plus cost of 2, 2, C of 1, 3 plus cost of 2, 3. So, finally, we get the min value as min of 13, 12. So, the final minimum value is 12. For the cost of 1, 1, the node 3 gives the minimum cost value. Next step, we have to find the minimum path. So, for that, we have to find D of 4, 7. The node which gives the minimum value. We already noted the minimum node that gives the minimum value. So, D of 4, 7 is 9. D of 4, 8 is 9. D of 3, 4 is 8. D of 3, 5 equal to 8. D of 3, 6 equal to 8. D of 2, 2 equal to 6. D of 2, 3 equal to 5. And finally, D of 1, 1 equal to 3. First, we have to frame the path. So, D of 1, 1 is 3. So, construct the path from the node 1 to 3. It is highlighted in this diagram. Next, D of 2, 3 is 5. So, construct the path from the node 3 to 5. Next, D of 3, 5 is 8. So, there is a path, minimum path from 5 to 8. Finally, D of 4, 8 equal to 9. So, construct the path from 8 to 9. So, the final path is from the source 1 to 3rd node. Next, we have to move on to 5th node and move on to 8th node and the final destination node. This is the minimum cost path. This is the algorithm for the multi-stage graph problem. There are 4 inputs, graph G, and K represents the number of stages, N represents the number of vertices, and P represents the minimum cost path. First we have to initialize the cost of N as 0. Next start the for loop J equal to N minus 1 to 1. We have to decrement the value in each step. So next we have to compute the cost of J. So let R be a vertex such that J comma R is an edge of G and C of J comma R plus cost of R is minimum. So cost of J equal to C of J comma R plus cost of R. Similarly, we have to initialize the P of J value as R. Next, we have to find the minimum path. So first initialize the value P of 1 equal to 1 and P of K equal to N. So for start the for loop for J equal to 2 to K minus 1. So initialize the value P of J equal to D of P of J minus 1. So end the algorithm. Thank you.